Hi, Econ students. Welcome to Micro Unit 3. We're talking production, cost, and perfect competition. This is where fives and fours are earned. It's Micro Unit 3. We're going to hit all of the biggest concepts, including what your most likely FRQs are going to be. So let's dive right in. Okay, so first we're talking about the production function. The production function is a graph, and you actually don't have to draw it. You just have to know how to analyze it and get the three stages of returns. We'll get there, I promise you. Here we go. So we're looking at inputs, outputs, and product in order to understand what the production function is. So we have a couple of definitions we got to get under our belts. First, we know that in order to earn a profit, businesses produce goods and services that then consumers like you and me buy to satisfy your utility. That is how an economy functions. In order to produce those goods, we know that the firms have to go to the resource market to get those resources, also called factors of production, right? And so they buy resources, combine those resources using their entrepreneurial ability to produce goods and services. Now we have a couple of different measures of production that utilize inputs and outputs. First is total product. This is a total quantity that is produced. Normally, we just call this the Q. It's the equilibrium on a supply and demand graph, so to speak. So that's total product. Next is marginal product. Marginal product is the additional product or additional quantity or output generated by one additional input. I think the easiest way to think about this is when you hire an additional worker, right? When I hire that next worker, how many additional units of output am I going to get? That's marginal product, also known as change in total product. And then finally, we have average product. Average product is the output per unit of input, right? So we take our total output and divide it by our total input, and that gives us our average. There you go. So if you're looking for your actual equations, marginal product is change in total product over change in inputs. Normally, the change in inputs is one. Almost always the change in inputs is one. So you can just look at the change in total product to get MP. Average product, of course, is your total product divided by your total inputs, or total output divided by your total inputs. And that will give you an average, how much output you get per resource you use. Okay, so those are the equations, those are definitions. What's it mean? Well, in order to figure that out, we have to understand two different types of inputs. There are fixed inputs and there are variable inputs. Fixed resources are resources that don't change with the quantity that's produced. For example, if we've got Johnny's Pizza here, a pizza oven is a fixed resource, right? In order to produce more pizzas, I don't need more ovens, right? I have one oven. I can produce a lot of pizzas there, right? If I want to produce more pizzas, I don't have to buy another shop. I don't have to buy another refrigerator. I mean, I might have to eventually, right? If I'm upping my quantity by a dramatic amount, I might need a second oven or I might need a second refrigerator. But generally speaking, those are fixed resources. In order to produce one additional pizza, I don't have to buy another oven. That's fixed. So land and capital, out of our two resources, tend to fall under that area. In order to produce more land or produce more of a good, I don't need more land. I don't need more capital or labor assists, right? Those resources are considered fixed. On the other side, you have variable resources. These are resources that do change with the quantity that is produced. Think of like inputs. If we're talking about pizza, if I'm going to produce more pizza, then I need more pizza dough. I need more pepperonis. I need more mozzarella cheese. I might even need more labor, right? Those are variable inputs. In order to produce more, I have to buy more of those inputs. So labor and materials tend to fall under this category. If I want more pizzas, I got to hire more people to do that, and I have to get more materials or the ingredients for a pizza in order to produce more. Hopefully, you see the difference between a pizza oven and pepperonis, right? Maybe eventually I'll have to get another pizza oven, but I'll definitely have to get more pepperonis if I want to increase the quantity of pizza I'm selling, right? So fixed resources, more capital, cash register, labor assist, ovens, refrigerators. Variable resources are the ingredients that go into a pizza, or the pizza chefs or the people making it in order to produce it. Okay, so keep that in mind. Next is the law of diminishing returns. The law of diminishing returns, you know already. We've talked about this before, but I'm going to give you a little bit more detail on the definition now. It's as variable inputs, like labor, are added to fixed inputs, like ovens or tools. The additional output produced by each individual worker will eventually fall. I'll say that again. As more and more variable inputs, like labor, are added to fixed inputs, like machinery, the additional output produced by each individual worker will additionally fall or eventually fall. Right? So let's take that pizza idea again here. If we have a pizza shop, when I hire my very first pizza chef, there he is, to produce pizzas, I'm going to get a whole lot of additional product or marginal product, right? I have one pizza oven, I have one chef. He's going to be able to make, I don't know, 10 pizzas in an hour because he's pretty skilled, he's pretty talented, and he's got an oven there. Things are good, right? Now, when I go and hire my second chef, who's, I guess, his identical twin, uh, if you type in pizza chef, this is the guy that shows up. Uh, so his identical twin, I hire him. Now they're going to be even more productive. Think about it, right? That one person before had to make the pizza, put all the ingredients on it, put it in the oven, right? Wait for it to get done, take it out, slice it up, put it in the box. A lot of steps that one person has to do. Now that I have two chefs, we can specialize. One of them can work on putting the sauce on the pizza and getting all the ingredients ready, throwing it in the oven. The other one can watch the oven, take it out, cut it up, put it in the box, right? Because they're specializing, they're going to be more productive than they would have been otherwise. So instead of 10 pizzas, you might be able to make 30 or 40 pizzas, right? Marginal product would be 20 or 30 pizzas by that next additional worker. So initially, when I add variable input, pizza chefs, to the fixed input, ovens, initially I'm going to have a boost in productivity. Okay. Let's say I hire the third worker. Maybe for the third worker, things continue to go up. We have even more specialization. Now I have the person who's making the dough and putting ingredients on. And then I have somebody who's putting it in the oven and watching the oven the whole time. And then I have one final person doing the final prep, cutting it up and putting it in the box. I split the task into three, and now we're even more productive than we were before. So marginal product might rise even more as I add those initial variable inputs, laborers or pizza chefs, to the same fixed inputs, one pizza oven. Now, when I hire the fourth worker, maybe that fourth worker gives me the exact same amount of productivity as the previous one, but now specialization is getting a little tedious, right? I have one person on the dough, I have one person on the sauce and cheese, I have one person on the toppings, and then I have one person taking it out of the oven. And I'm not getting the same gains as I did, especially when I got the first or the second worker. Now I have the fifth worker, and now they're tripping over each other, right? They're getting in each other's way. They're not able to get any more pizzas in the oven, so they're no more productive than they were before. And I start to see my productivity fall. By the time I hire my sixth or my seventh or my eighth or my ninth worker, now they're literally on top of each other. They can't move around. Productivity might actually fall, diminish, and decrease, right? Now, this is an absurd example, but that's what we're talking about. That's a production function. Initially, when I add variable inputs like a pizza chef to a fixed input like an oven, initially I'm going to have a boost in productivity because they can specialize. After a little bit, though, my productivity, additional product, is going to start going down. It's still positive, but it's going down, right? It's not as productive. Maybe the fourth or fifth chef is only adding three or two additional pizzas, whereas the second chef added 30 additional pizzas. By the time I get to my eighth and ninth chef, it's actually harming productivity. Total product is going down. Had I not hired that eighth or ninth, I would have made more pizzas total than I would have otherwise. So it gives us three stages of returns. So let's take a look at this production function in graphical form. It looks like this, right? We have three stages of returns. The first stage is what happened when I hired my first couple of workers, right? We call this increasing marginal returns. And increasing marginal returns, marginal product, which is this top one here, marginal product, which is the bottom one here, this is called marginal product, is increasing. It's going up. Meaning when I hired the first worker, he made 10 pizzas. When I hired the second worker, I got 20 additional pizzas, 30 total. I had the third worker, I had 60 additional pizzas. So 90 total or something like that, right? You can see that we have increasing marginal product. And my total product is going up at an increasing rate, which is this convex slope, like you're going up a roller coaster, right? Stage number two, oh, I'm sorry. The reason for that is we have these gains in productivity because they're specialized. One's working on the ingredients, the other's watching the oven, the third is putting it in the box, right? The next stage, this yellow stage right here, stage two is decreasing marginal returns. Notice my marginal product is going down. When I hire workers here, marginal product is falling, right? It's going down. Each worker is still giving me additional pizzas. There's still a positive number, but it's lower than the person before. So remember, our second worker gave us 30 additional pizzas, but my fourth or fifth worker might have only given me 5 additional pizzas. Well, that's significantly lower than 30, but it's still more pizzas than I had before. So total product is still going up, but it's tailing off at a decreasing rate. Where marginal product or the additional pizzas that individual can produce is going to be going down. The reason for this is we have fixed resources. Each worker that I add to that fixed resource is going to add less and less and less and less. My final stage of return is negative marginal returns. For negative marginal returns, marginal product is negative. This is where they're getting in each other's ways. They're having arguments, right? Things are bad. Marginal product is going to show up as negative or sub-zero here at this point, and total product is going to be falling as a result. At this point, hiring that additional worker is actually making me produce less or fewer pizzas than I was before. And the reason is because the workers or the variable inputs are getting in each other's ways. They're coming up the works. They're making it difficult to do what we did before we hired those workers. Notice too, average product. When marginal product is above the average product is going up. As soon as marginal product falls below it, average product is starting to go down. I think the easiest way to think about this is think about how averages work when you have a new additional data point. For example, if we took the average height of our classroom, when Mr. Peters walked into the room, that's marginal, additional data point. Mr. Peters walks into the room, he's like 6'8, 6'9, he's huge, right? What happens to our average product or average height? It goes up, right? So when marginal product is above average product, it's going to pull it up. And then if somebody very, very short, we won't point fingers at anybody, walks into the room, that's a new data point. They're below the average. They're going to pull the average down as a result. So whenever marginal product or the additional data point is below average product, it's going to fall down. All that to say that marginal product will intersect average product at the peak optimal point. Okay, so let's take a look at this in a chart form. Over here on the left, here, let me get myself out of the way. We have our input of workers. Next, we have our total pizza. Can you calculate marginal product? Well, we know marginal product is just the change in total product divided by change in inputs. So change in total product is right here. Change in input is 1. So 10 divided by 1, marginal product is going to be 10. Can't find the marginal of the 0. When I hire my second worker, I go from 10 to 25. Right? Divide that by 1, so that's going to be 15. When I hire my third worker, I go from 25 to 45. So my marginal product is going to be 20. Notice, each time I hire one of these additional workers, first, second, third, I'm getting increasing marginal product, meaning we're more productive than we were before because we're able to specialize. When I hire my fourth worker, I go from 45 to 60, my marginal product is 15. Notice that person still added units, but it's less than the person before. So we started to see diminishing returns. It's positive, but it's lower than 3. So at 3, that's my turning point. After that, I no longer have gains from specialization. I'm now starting to see the consequences of adding variable units to fixed resources. Okay. Next up is fourth to fifth. So I'm going from 60 to 70. So that's going to be 10. 70 to 75. So that's going to be 5. 75 to 75. That's going to be 0. Oops, 0. And then 75 to 70. That's going to be negative 5. So far, so good. Hey, I did the calculations right. Okay, next up, can you calculate, can you calculate average product? Should be able to. Remember, average product is pretty simple as well. It's just total product divided by inputs. So this one is going to be 10 divided by 1 or 10. This is going to be 25 divided by 2 or 12.5. There we go. This one's going to be 45 divided by 3. I no longer can do that work in my head, so I'm just going to hit the button and boom, I got it all. Oh, 45 divided by 3 is 15. I knew that. Right? So you see your average product here. Notice at the peak of average product, that's where we're going to intersect with marginal product right there. That's the height of average product. At that point, marginal product is going to fall below that and it's going to pull it down. Okay, that's not really that important, but can you identify the three stages of returns? Well, remember the first stage of return is increasing marginal returns. So that's going to be located here from 1 to 3 because at this point, my marginal product is going up. I hire my first worker, it's 10. My second worker, it's 15. My third worker is 20. I have specialization, which is giving me considerable gains. And total product is going up at an increasing rate. Next up, we have our constant returns, where or diminishing returns, sorry diminishing returns where additional units still results in a positive number. 15's positive, 10's positive, 5's positive, but each one is less than the one before because I have diminishing returns. I'm experiencing the squeeze of adding variable inputs to fixed resources. Okay. Then finally, we have our negative returns, and that's when our marginal product goes negative, meaning these resources, the eighth worker, for example, is just getting in the way, gumming up the works, making everything terrible. It's all falling apart. You're actually losing productivity as a result. So those are your three stages of returns. Final example for you, something you might have experienced in your own life is studying for an exam, right? Your variable is the hours of studying that you can put towards something. And your fix is performance on the exam, right? So you might see it like, hey, if I study 1 hour of studying, I'm going to have significant gains on that exam, right? Maybe the second hour of study, I'm going to be even better on the exam. Maybe I have the potential to get an A. You get to your, or like a 95, for example. You get to your third hour, and now maybe the gains from your exam might only be like a 96 or a 97, so it's not that much. You get to your fourth hour, your fifth hour, you start to see diminishing returns, right? You're still in the A range, but you're not seeing any gains. It doesn't make you better at the exam when you're in your fourth or fifth hour. By the time you spent 10 hours, you've done an all nighter, you're now robbing yourself of your resources you need to actually perform well on the exam. It's going to start to diminish your outcome. So instead of an A, maybe now you're going to get a B or even a C because you spent too long studying. That's the idea of the three stages of returns. Initially, gains, right? Increasing total product at an increasing rate, and positive or increasing marginal product. Second stage, diminished returns. Marginal product starts to fall. Total product's still going up because it's still positive numbers you're adding to it, but it's tailing off. And then finally, you have negative returns where marginal product is negative and we see a decrease in total product. All right, that's all you need. Khan Academy production function is ready for you. See you in class. Peace.